Good day, mathletes. Today we'll talk about the Cartesian coordinate system, also known as the Cartesian coordinate plane. But before we get started, let's take a look at the history of the Cartesian coordinate system. And to begin with, a French mathematician named René Descartes devised the Cartesian coordinate system while lying in bed, sick or unwell in 1637. While lying in bed, he noticed a fly flying around on the ceiling, which was comprised of square tiles. As he stood there watching, he realized he could describe the fly's position using the ceiling tile he was standing on. Then, he created the coordinate plane as a result of this experience to make describing the position of objects easier. Okay? So, he created the coordinate plane as a result of that experience to make describing the position of objects easier. This Cartesian coordinate system has its many practical applications in the fields of engineering, such as building bridges, roller coaster design, rocket and satellites, satellite navigation, digital music, MRI and tomography, and even our computer games nowadays. So it uses actually the concept of the Cartesian coordinate system, or the Cartesian coordinate plane, or also known as the rectangular coordinate system. Okay? So that's a little background or history about our topic today, Cartesian coordinate plane. Now, we're going to discuss what is Cartesian coordinate plane. Okay? And to do that, let us have here a slide. Okay? That's it. So, the Cartesian coordinate system. Um, I know that you are quite familiar with our number line, right? So, a one-dimensional number line here. This horizontal line is what we called a one-dimensional line, or the number line. So, we can represent real numbers geometrically by points on a real number, or a coordinate, or a line. Okay? Then, if we're going to add another number line, this time a vertical line, okay, if we're going to extend the concept of number line, so into two-dimensional space by adding a vertical axis. And this is actually the vertical axis, okay, or what we call the standing line. And in the Cartesian coordinate system, this horizontal line is what we call the x-axis, okay? And this vertical line here is what we call the y-axis. And the point of intersection of these two number lines here is what we call the origin, okay? So take note, the point where the two lines intersect is what we call the origin. The origin actually has a coordinates of 0, 0. And we will learn about that more later. So in this horizontal number line called the x-axis, from 0 to the right, this is what we call positive direction, since all the numbers here are all positive. While from 0 to the left, all the numbers here are negative. That is why we have here negative direction. And in the y-axis, positive numbers are above. So from 0 upward, we have positive integers or positive numbers. And from 0 below or downward, we have negative direction or negative numbers. And a point in the plane can now be represented uniquely in this coordinate system by what we called an ordered pair of numbers. Okay, take note of the term ordered pair. Okay, ordered pair. That means the ordered pair must be written x, comma, and then y. So it should not be written as y and then x. So that's another topic. But generally, we represent the ordered pair as x and then y. Okay. So x here represent the numbers in our x axis, and the y here are the numbers in our y axis here. Okay? Supposing we have our x is 4, so we are going to locate 4 in the x-axis, and our y is 3, so we are going to mark or locate 3 in the y-axis, and then we're going to trace from 4, we are going to trace so which point actually the two numbers will intersect. So this is actually the coordinate, okay, of the point, coordinates of the point. And this point actually has an ordered pair 4, 3. Okay, that's it. And the axes divide the plane into 4 regions, what we called quadrants. Okay, so take note that these two axes here, x-axis and the y-axis, divides the plane into 4 regions. We have 1, 2, 3, 4 regions called the quadrants. Okay, we called these 4 regions here quadrants. And the quadrants actually uh, was named counterclockwise. Counterclockwise means from point going to the left. Okay, it's not going to the right, since the clock moves uh, from a certain point going to the right. But when we say counterclockwise, from a certain point going to the left. So supposing, so we have this point here, that means we are going to move to the left here, to the left. So from this point, so counterclockwise, starting from this region, so this region is what we call the quadrant 1. So we use the Roman numeral to name the quadrants. So quadrant 1, and in quadrant 1, the coordinates actually are both positive. X is positive and y is positive. So we have here x and we have here y. So recall earlier that from origin to the right, we have positive direction. From origin upward, we have positive direction for our y-axis. So the coordinates actually have a coordinate have signs both positive. And next, to the left, we have quadrant 2, where the coordinates are negative and positive. So x here is negative since we are using this part of the x-axis from the origin to the left, so negative direction, and our y here is positive. And below we have quadrant 3. So in this quadrant, x and y are both negative. Okay? So x here is negative and y here is negative as well. Since we are using this part of the x-axis, which are all negative numbers, and we are using this part of the y-axis, which are all negative numbers. And lastly, we have quadrant 4. In quadrant 4, x is positive and y is negative. Okay, so you have to make yourselves familiar with the signs of the coordinates in every quadrant so that it will be easier for you to determine or to locate a certain point in which quadrant the point lies actually. Okay, that's it. Okay, so let's not discuss this one. So here is actually a graphing tool we can use um, to plot points on the Cartesian plane. Actually, you can download this on your Android phone or smartphone. The name of the graphing tool actually is GeoGebra, and I think this is free. Okay, but it would be a lot better if you make a Cartesian on your own. Okay, so that you will be familiar of the different parts of the Cartesian plane. Let's say here, uh, let's have an exercises here. So we have named the point that has coordinates 2, 2. Letter A, we have 2 and 2. Let's make this a little bigger here. So name the coordinate. Mm-hmm. 2, 2. Uh, where can we write? Okay, 2 and 2. Sorry. So observe that the sign of the coordinates are all positive. X is positive 2 and y is positive 2. So that means we can find this point in the first quadrant. Okay? So we're going to locate first 2 in the x-axis, on the x-axis here. So this is actually 2. Okay? So from this point, and our y is positive 2, so we have this point. So from this point, we are going to trace where the two numbers will intersect. And we have here this point. So the coordinates 2, 2, okay, have this, or the point lies here in the first quadrant. So we name this L, okay? So point L. This one. This is point L. How can we use... Sorry. This is point L. And let's proceed to letter B, negative 6, 2. So the coordinates actually, x is negative and y is positive. So in which quadrant can we find x is negative and the y coordinate is positive? So we have in the second quadrant. So here is negative 6 and then here is negative 2 and the point is D. So we have point D. Point D has a coordinate negative 6, 2. So we simply write the capital letter D. So you have to take note that we named the point on the Cartesian coordinate plane using a capital letter, not a small letter. And let's have letter C. X is positive and y is negative. So we have 1, negative 4. So in which quadrant can we find the coordinates positive and negative? So we have on the fourth quadrant. So we have 1, here is 1, and we have here negative 4. And we have here point K. So letter C actually is point K. Let's have letter D. 0, negative 6. Okay? 0, negative 6. It might be possible that the point actually do not lie on the four quadrants. If the points do not lie on uh, any four quadrants, that means the line or the point rather lie on the axis. Okay, either the x-axis or on the y-axis. So we have 0, negative 6. So x0 meaning it's here. X is 0. And then y is negative 6. So we have here from this point we move downward to negative 6. And we have here F. Okay? So we have point F. And then letter E, we have negative 4, negative 2. So we have to tell first in which quadrant the coordinates have sign or both negative. So negative 4 and negative 2, it's in the third quadrant. So here is negative 4 and here is negative 2. And the point is J. So we have point J representing the coordinates negative 4, negative 2. Okay? So I hope you have now the idea on how to find or locate a certain point on the rectangular coordinate plane or the Cartesian coordinate system. So let's answer here number 2. Write the coordinates of each point. So we have letter B. So on our Cartesian coordinate plane here, we are going to find letter B. And we have here letter B. Okay? And the x coordinate is 5 and the y coordinate is 5 as well. Okay? So we simply need to trace the point on the x-axis and on the y-axis. So the coordinate actually is 5, 5. Okay? So it's 5, 5. So we have here 5, 5. Okay, so point B has coordinates 5, 5. Then letter G. So let's find letter G. Okay, we have it here, G. And then we're going to trace this point to the x-axis. So we have 6. And our y-coordinate is negative 3. So therefore, point G here is 6, negative 3. Okay, so point G has coordinates 6, negative 3. Then letter C, we have point E. And we have here point E. Again, trace the point on the x-axis. So we have negative 6 and then negative 5. So the coordinates therefore is negative 6, negative 5. So we have here negative 6 and negative 5. So take note that we need to enclose the coordinates in parentheses. Okay? Because that's the proper way of writing coordinates. Then letter D, point N. So we have here point N. So point N, trace this point toward the x-axis. So we have negative 2 and we have 3. So we have negative 2, 3. Okay. So negative 2, 3. Then the last item, we have letter E and we have point H. So we have here H. Okay? So if the point lies on the x-axis, so therefore automatically the y-coordinate is 0. Okay, you have to remember, if the point lies on the x-axis, the y-coordinate is 0. If the point lies on the y-axis, the x-coordinate is 0. So we have here x is 4. Okay, and the point actually is on the y-axis, x-axis rather. So therefore y here is 0. So therefore the coordinates of point H is 4, 0. Okay. Next, number 3. In what quadrant is each point located? So letter A, we have point C. Okay? It's what quadrant? We have quadrant 2. Okay? Quadrant 2. Letter B, point J. Point J is here. We have quadrant 3. Letter C, point L. We have quadrant 1. Letter D, point M. Point M is here. We have quadrant 2. And we have letter E, point K. Point K is in quadrant 4. Okay, that's it. Then let's have number 3. Okay, so plot each set of points on a different plane and join them in order to form a quadrilateral. Okay, and identify the figure. So what type of figure we have? Identify the quadrilateral. So we have here letter A, point B, point C, and point D. So point A has coordinates 1, 1. Okay. We're going to use this Cartesian coordinate plane. Okay. So you can actually adjust the numbers here depending how big the number is. We can actually have here 5, 10, 15, 2, 4, 6. So that depends. Okay, if you have a limited working space, so you need to adjust how are you going to calibrate your Cartesian coordinate plane. So letter A, we have 1, 1. Okay, so to plot a point, so we need to determine or locate the x coordinate. We have 1, and the y coordinate is 1, and then we're going to trace where the two numbers will intersect. So it's here. Okay, it's here. Let's see. So let's have a point. So the two numbers intersect at this point. So we have here letter A. Sorry. Okay, that's it. So point A. Okay, then letter B, or point B rather, has coordinates 1, 5. So we're going to locate on the x-axis. So we have here 1. On the y-axis, it's 5. So take note the coordinates are positive. So meaning it's in the first quadrant. So 1, and we have 5. And then we're going to trace where the two point will intersect. So we have here. Okay. So that's point B. And letter C, we have 3, 5. So we have here 3 and we have 5. So that means if we're going to trace from here on, from this point and 5 here, so we have this point. I'm sorry. Okay, we have 3. Uh, let's make our working area a little bit wider. And we have C3, 5. Okay, we have here 3 and we have 5. So we have this point. Then we have point D, we have 3, 1. 3, 1. So we have here 3 and we have 1. So the point lies here. Okay. Then according to the directions earlier, we are going to tell what uh, figure actually is formed. So we have here, if we're going to locate, okay, so we have line. Let's see. So what kind of, that's it. There. So what kind of quadrilateral do we have here? We have a rectangle. Okay, so we have here rectangle. Okay, that's it for letter A. Mhm. Then let's have our next example, letter B. Point J. Let's have it here. Hmm. There. Letter B. So point J has coordinates 1, 3. So we have 1 here and we have 3. So therefore, we have 1 and then 3. And this is actually J. This is J, right? 1, 3. So this should be J. Okay. Then we have point K, 5, 1. Let's have here 5, 1. So we have 5 and then we have 1. And the point lies here. So this should be JK. We have to name this K. Then point L with coordinates 8, 1. 8, 1. Okay. We have 8, 1. Let's move this. 8. So we have here 8 and we have 1 here. And the point is here. Okay. And then point M with coordinates 4, 3. So we have here 4 and we have here 3. So the point lies here. And this is point M. Okay. So what type of quadrilateral do we have here? So from this point, I don't know if we can have a line here. Let's see. No. Draw a line. Where is that? Well, let's choose this one. Okay. There. And there. 4 3, tama ba? 4 3, 8 1, 5 1, and 1 3. 1 3. I'm sorry. This is supposed to be here. There. And here. And here. So what type of quadrilateral do we have here? Okay, so this is actually a parallelogram. So letter B, the quadrilateral is a parallelogram. Okay? Next, let's have letter C. P with coordinates 3 0. So 3 0. As I've said, if the y coordinate is 0, meaning the point lies on the x-axis. So positive 3, that means on positive x-axis. So the point lies here. So we have letter P. Then point Q. 6. I think this is -2 or 2. Let's see. 6, 2. So we have here 6 and we have here 2. So that means we have here, and this is P point Q. Okay, and we have R, point R with coordinates 5 2. So we have here 5 and we have here 2. So we have here 5 2. Q R and 2 0. So we have 2 0. Again, the y coordinate is 0. That means the point lies on the x-axis. 2 0. QRS. So if we're going to if we're going to let's use this instead of the first one we used. Then here, if we're going to connect the points there, okay. So just like we have earlier, we have a quadrilateral as well. I'm sorry. They are all quadrilaterals. We have what type of quadrilateral? We have parallelogram. Okay. So letter C is an example of a parallelogram. Okay. That's it. And let's have letter D. Point W, 1, 1. Point W with coordinates 1, 1. So we have 1, 1 here. So the point lies here. Then, so we have point X, okay, and a point W, I mean. This is W. And point X, 0, 3. So in this case, X is 0 and Y is 3. That means the point lies on the Y-axis. Y is positive, so therefore, on the positive Y-axis. So 0, 3. So the point lies here. WX. So we have here X. And point Y with coordinates 4, 1. So we have here 4, we have 1. And the point lies here. X. So we have Y. And lastly, we have point Z with coordinates 3, 1. So we have 3 and we have 1 here. So the point lies here. Did we plot the correct points? 1, 1. So 1, 1. Sorry. 1, 1. 0, 3. And 4, 1. Yes. And 3, 1. So I don't know what kind of quadrilateral do we have here. I think this is not a quadrilateral. Okay. So 1, 1. 1, 1 from this point to this point. Then 0, 3 and then 4, 1. And 3, 1. This is supposed to be, sorry, 3, 1. So this is not a quadrilateral. If we're going to close the figure, this is a triangle. So maybe there's some typo error here. Okay, so we cannot actually avoid errors. So let us not consider letter D. Okay, for this one, since the figure actually is not a quadrilateral, maybe there is something wrong with the coordinates. Okay, anyway, what's important here is you already know how to plot the points on the Cartesian coordinate plane, right? Okay, then let's proceed to number 4 here. To number 4. So in which quadrant would the following points be found? Okay, so just determine the sign of the coordinates, the x and y coordinates. So in number 1, we have 1, 1, all positive, meaning we have quadrant 1. Okay? This is actually in quadrant 1. In number 2, positive, all the coordinates are positive, quadrant 1 still. Number 3, 2, 1, all positive, so quadrant 1 still. 4, negative 1, 2, okay. Um, X coordinate is negative and Y is positive, so this is in quadrant 2. Again, number 1 is quadrant 1, quadrant 2 is quadrant 1 as well, quadrant 3 is quadrant 1, quadrant 4, negative, X is negative, Y is positive, so it's in quadrant 2. Number 5, so no matter how big the number is, just focus on the signs of the coordinates. Positive, negative, so it's in quadrant 4. Number 6, all the coordinates are negative. So negative 1, negative 1, it's in quadrant 3. Okay, so hopefully you learned from our discussion about the Cartesian coordinate system, or also known as the rectangular coordinate plane. So we will have more uh, topics about Cartesian coordinate system, and what's important here is you know the basics about Cartesian coordinate system. So that's all for now. Good day and good vibes.